Come on. Welcome back, everyone. And today, as I said in the some video, it should appear here. I am going to answer your questions about Dark Fist. No, answer questions about 0.000000 not being 9 of 1 not being of 1 not being equal to 0.999. So I said in the last video, I told you all to leave down. Yeah, I'm sorry that I cannot speak, but man, am I tired today, and not only that, it's late, so I will have problems with talking, thinking. So, oh right, that 0.999 isn't equal to 1, and uh, oh, I told you all to leave comments down below if you have or might have some problems with it, and I was supposed to answer them in two videos from that one. So now that I posted these two videos, I'm going to answer you all these questions. Sadly, most probably I'm not going to show which ones am I answering, so you will just have to hope. There isn't much more. So, let's start from the simple one from Traktora 1. Interesting name. But besides, now I will read that comment. 1/3 is equal to 0.33333 repeating. Let's multiply both sides with 3. 3 times 1/3 is equal to 3 times 0.33333 repeating. Let's open the brackets. The left side size is easy, but if we multiply 3 in every right side, we get a 9. 1 is equal to 0.999 repeating. The problem with this weird equality is that decimal numbers are imperfect shorthand of writing rational numbers. In this particular case, we have 1/3 a simple rational number that can't really be expressed in decimal format. For that reason, we had to come up with a way to write it down for all practical purposes, and while this is way easy, and this way is easy, I can't read, is easy to read, it's not perfect. There are multiple other proofs, but even the simplest ones require some basic but fundamental knowledge of calculus, definitions of different numbers, and of real space. Well, how am I supposed to say this, but... I have not yet learned calculus. You might be surprised or not, but I'm still in primary school, so I don't really have any way of knowing that. But besides, let's get to the main topic. So 130 0.333333 repeating. And how could I disprove this? Just so you aren't bored, I'm going to pause filming and resume when I have an idea. Okay, I have an idea. So 0.33333333 is equal to 1/3. That's normal. And also 1/3 is equal to 1/3. Also 0.333333 is equal to 0.333333, repeating, of course. When I say 333333, I mean 33333 repeating. So if we try to multiply those by 3, we get 3/3 is equal to 3/3. So 1 is equal to 1. And when we use 0.33333333 repeating, then we get 0.9999 repeating is equal to 0.9999 repeating. And what does that show us? That they aren't the same. I mean, if we really take this, then it shows us that they are not the same. Why? Because they should give, well, the same answer. 1/3 is equal to 1/3. And because 1/3 is equal to 0.33333 repeating, then 0.33333 repeating is also equal to 1.2. Yeah. To 1/3. And because of that, we can change 0.3333 to 1/3. And then we get 1/3 is equal to 1/3. I do not know if I'm saying third right or not, but I'm not good at English, I'm sorry. So, I don't know, I proved that 0.3333 repeating isn't 1/3. I mean, I guess so, because you can clearly see that 0.999 repeating isn't equal to 1. But you might say that just because it doesn't look like it does not mean that it isn't. I mean, some numbers can look finite when they are infinite. And I can't really argue with that, because I dealt with those numbers before. While solving the twin prime conjecture, I solved it. I'm planning to make a video, but before that I will do still a few about mathematics. Of course, my own developed mathematics. But going back to what I was talking about, 0.3333 repeating cannot be equal to 1. Not equal to 1, to 1/3, I'm sorry. 0.3333 repeating cannot be equal to 1/3. Because they give two different answers. I don't really know how to say that, but I think this is the only way to prove that it isn't, because I don't see too many more of them, but I haven't thought about that. I'm not kidding, I am thinking right now about how to solve them. I have not even tried before. This is all from the get-go. Because I'm dumb enough to not try and solve them before making this video. Okay, because it's starting to be quite too long, so let's just get to another one. Now from Shash the Boy. Interesting name. Well, only 0.999 doesn't equal 1, but 0.999 repeating does. Why? Since there are infinite 9s, making a real number that lies between 0.9 repeating and 1 is impossible. If we assume I don't it's not important. 0.9 repeating is equal to x. We multiply both sides by 10. We get 10 times 0.9 repeating is equal to 10 x, which is equal to 0.9 repeating. Subtract the dx, we get 9 repeating minus 0.9 repeating is equal to 9, which is equal to x, to 9x, x. And then x equals 1. Also, 0.9 repeating subtracted from 1 would actually be 0, since 0.9 repeating has infinite 9s, and there is no number between 0.9 repeating and 9. And well, pretty good argument, I say. Also a basic one, because, well, I know about this argument that we multiply both by, as we say that this is equal to that, we multiply by 10, subtract the same, and then we get that. So, there is no problems but one. One teeny tiny, not really important problems will destroy your whole argument. You can always add one more 9. Why? 0.999 repeating has infinite 9s. The definition of infinity is that we can always add one more, always. And that means that to 0.999 repeating, we can add another one, and another one, and another one, another one, another one, and two more, more, and more. And it will still be infinite 9s, and it won't really change structure. But will it? But well, then it won't really be the same, will it? Okay, that sounded a little bit weird. But besides, is 0.9 repeating equal to 0.9 repeating plus... how many was it? 14, 16, 18? More 0.9... more 0.000 infinity after 9... no... x is 0.9 repeating equal to 0.9 repeating extended by 14 decimal places? Because from one side, we get that... oh, my filming and time clock is synchronized. But besides, we get that... how do I wrap it up in words? If we extend the infinity by more decimal places, it shouldn't really change. At least I think so, because then we are giving infinity a finite value. Very large, but still finite. Wait, so can even there be 0.9 repeating? Hmm. 0.999 repeating, extended by decimal places. Wait, I need to think about that. Oh, I know. Hmm. So, you know, it might seem weird what I'm about to say, but infinity is finite. Yes, I am not kidding. Why? Because 0.99999 repeating can be still extended. Because that's the definition of infinity. We can always extend it. So if I extend it, then it's clearly larger. You might not think so, but if we were to count over an infinite amount of time, well, then after that we would just get that one number is bigger than another. I do not know if my reasoning is very good for that, but I think so. So, zero point 0.99999 repeating is finite. It cannot be infinite if we can always extend it. Because, well, that's a contradiction, logical contradiction. That 0.999 repeating would be not equal to 0.999 repeating extended by another decimal place. Yeah, I'm also surprised, just by like you. So, to solve this, I propose a new kind of unit. Uncountable. Like there are infinite things, there are also uncountable. So those which we could not count, no matter how much time would we get. Therefore, infinities are not equal to each other, and even infinities are not are not infinite if we can count them. Because if we are given enough time, we will reach the end. And what is the purpose of uncountable? Well, they are, let's say, another step in the journey to basically absolute infinity. It's just another step. So there is finite, there is infinite, and there is uncountable. Finite, we can do in a finite amount of time, we can do something. Infinite, we can do it in a infinite amount of time. And that time has to be equal to the let's say an equation that we would have to come up. And so here, if we wanted to count every single 9, then the equation would be uh, 9's counted is equal to speed of counting times time. You get me? Good. And uncountable is another or even higher level that we cannot count no matter what. Even if we have uncountable speed, uncountable time, anything uncountable, we cannot count it. We cannot calculate it. We will never know. So, like, let's say P. It's not infinite. It's uncountable. Euler's number, same thing. Golden ratio, same. And much more I don't know because, well, guess what? No, I did not mean that. Of course, why? Of course, I have to be in primary school. I'm going to finish it in a 2 months, but before I learn everything in middle school, it will take a while. So basically, 0.999 is infinite, but it is still not equal to 1. Wait. Because we can always move by 1 decimal place. We can always add another 9. So we can make another number that is even closer to 1. And we can do that infinite amount of times, or even uncountable many times. But it will still be infinite, not uncountable. Because uncountable, it's not something you can reach. It's something that you are born with. Man. Okay, I have to wrap it up fast because I'm losing too much water because it's too hot here. So, wrapping it all, it's going to be all. It was nice to meet. It was nice to answer to your questions. I am happy that you tried to do something. And I'm not going to answer the comment of Cantoros because, as I said, I do not know calculus. So I'm sorry that I could not do everything. I would really love to. And, well, for today, it's going to be all. See you in the next one. But before you go, don't you even try to get away. Before you go, here is that video in which I tried to prove. And, well, that is really going to be all for this one. No, I'm going to wait here, so maybe you click on it. I'm not going to say anything more important. Besides that, the next one is going to be about dark physics. I think so. Yeah, I do about dark physics, so thank you all for watching. See you on the dark physics topic. You clicked already? Okay, bye. Yes, I do really want you to click on that. But now seriously, all.